Modeling with exponential functions, part 2. The population of a certain species of fish has a relative growth rate of 1.2% per year. It is estimated that the population in 2010 was 2 million. Find an exponential model, estimate population after how many years, and then sketch a graph. Okay, so here's our model. N sub t equals n sub 0 e to the rt. Here's our model here. Remember, it's important to go through and make sure you know what each variable represents. N sub t is the size of the population at time t. N sub 0 is the initial size. R is the relative growth rate expressed in decimal when we plug it into the formula. And then t is time. Once we know what our variables represent, we can go back and fill in some of their values. Of the population of a certain species of fish has a relative growth rate of 1.2% per year. Okay, so relative growth rate was our R value. So what we know is R is equal to, make that a little bit darker, R is equal to, turn it into decimal, 0.012. So there's our relative growth rate. It is estimated that the population in 2010 was 12 million, and T represents the years after 2010. So in 2010, that would be 0 years after 2010. So what this is saying is when t is equal to 0, the fish population is 12 million. And that's your initial value. When time is 0, time or anything starting at 0, that's your initial. So n sub 0 equals 12 million. Okay, so find our exponential model. So let's go ahead and see if we have enough information for that. N sub t is equal to n sub 0, which is our 12 million, e raised to the r, which is 0.012, and then our variable t. We did have all the information that we needed. Okay, estimate the fish population in the year 2015. Okay, so we're going to go back and remember if t equals 0 means the number of years after 2010. If we're looking at the year 2015, we're going to use a t of 5. So we have n of 5 is equal to 12 million e to the 0.012 times 5. Okay, so we'll grab our calculator. We'll plug in some numbers. 12 million times e to the 0.012 times 5. And the extra parenthesis, we're looking at 12 million. $742.39. We can't have half of fish, so we'll go ahead and count the whole fish. So 12742,039. After how many years will the population reach 4 million? And then we're going to sketch a graph. Okay, so let's look at when will the population be 14 million? After how many years we're solving for t? So we have 12 million e to the 0.012 t. We'll divide over that 12. And we could go ahead and reduce further, but I'm just going to leave it like that for now. How to get rid of E? We're going to ln both sides. 14 over 12 reduces to 7 over 6. ln and E cancel each other out. They're inverse functions. So all we have to do is divide over that 0, 1, 2. Okay, so let's plug in. We've got the natural log of 7 over 6. We're going to divide that by 0.012, and it'll take about 12.9 or 85, 12.85 years. Okay, so let's sketch the graph of the function. So we're going to y equals, we'll clear out any old stuff that was there. We'll put in our new original equation, which is this one, 12 million e to the 0.012 t. Okay, so window. When I plug in 5, I get 12.7 million. When we plug in 12.9, we're up to 14 million. So that gives us an idea of our window. So I'm going to go say 0 to, let's go to 20 in tick marks of 5 units. And then we'll start at 0. And actually that would be a little bit too small. If we're already up at 12 million initially, maybe we better start at, let's say 10 million. And we'll go to, say, 20 million. Okay, so let's see how that looks. If it doesn't look good, we could always regraph. But I think that's okay. Now, what I'm going to also put in here was another way to do part C. How many years will we reach 14 million? I'm going to go ahead and graph that horizontal line, 14 million. And what we could do is we could check our by hand answer by looking for that intersection point. Second, calc, intersection. We move our cursor to the point of intersection and then hit enter 3 times. First curve, enter, second curve, yep, we're still there. Do I have a better guess? No, enter. And as long as this word comes up, intersection, then I know the calculator reached an answer 12.845, which is the same thing we got by hand. So we're sure that we have a good answer. Okay, so I'm going to grab this graph and put it on our slides so that I can save, and we have all parts ready to go. Okay,